Hello everyone. Today's topic is higher order partial derivatives. We go to the next slide, and I'm assuming that we already know what is a partial derivative, and we calculate a partial derivative for function of two or more variables, or you can say a function, multivariable function. So for simplicity, I'm considering z as a function of two variables. You can actually have z as a function of multiple variables, say x1 comma x2 comma dot comma xn. And one more thing to remember is, since z is a function of two variables, when you partially differentiate z with respect to x, y will be treated as constant, and when you partially differentiate z with respect to y, x will be treated as constant. So that means z is going to have two first order partial derivatives. So that is going to be one with respect to x and the second with respect to y. Here I'm going to write down a number 2 raised to 1. Here 2 represents the number of variable and 1 represents the order of differentiation, and 2 raised to 1 is equal to 2. So it tells you that the z will have two first order partial derivatives. So let us see what are they. So first is dou z by dou x, and second is dou z by dou y. Now let us see what will be the partial derivative of dou z by dou x, and they are actually called as second order partial derivatives. So we are now going to higher order partial derivatives. Now, so you are going to calculate this with respect to x and this with respect to y. So let us see what is the derivative of that with respect to x. So you can see that derivative of z with respect to x and again x is dou square z by dou x square. Similarly, the second order partial derivative of this with respect to y is going to be dou square z by dou x dou y. Again, now this first order partial derivative will also have two more partial derivatives, because since both of these first order partial derivatives are functions of x and y, so we keep on getting two more partial derivatives as you go on to the next level of or next order of partial differentiation. So the partial derivative of this with respect to x is going to be dou square z by dou x dou y. You can see that these two look alike, but they are different because here the order of differentiation is x first and then y, and here the order of differentiation is y first then x. And remember that the order of differentiation is from right to left. Therefore, whenever you read such partial second order partial derivatives or higher order partial derivatives, or they are also called as mixed partial derivatives, you have to read it as dou square z by dou x dou y. So right to left. Okay, the next one is the partial derivative of z with respect to y and again y. So it gives you dou square z by dou y square, and you can see that if I write this 2 raised to 2, 2 is the number of variables and 2 is the order of differentiation, and that is 4. So you get 4 second order partial derivatives. So that means I can guess how many will be the third order partial derivative, that is 2 raised to 3, 2 being the number of variables, 3 is the order of differentiation, so that is going to be 8. And it is obvious because each of these 4 partial derivatives, second order partial derivatives, will have 2 more third order partial derivatives with respect to x and y. So let us see what are they. So this is dou cube z by dou x cube. You can see that z is differentiated partially with respect to x, again x and again x, therefore you have x cube. So I can just go ahead and give you all the partial derivatives here now. These are all third order partial derivatives. If you want, you can pause the video and take a look at all these partial derivatives. Okay. Uh, Now, if you look at this third order partial derivatives, again, if you look at this partial derivative and this partial derivative, they seem or look alike. Means it seems because it is written dou y. So dou y is 2 times, dou x is once. Here again dou x is once and dou y square. So this is actually dou y into dou y. Even though they look alike, but they are not same. Why? Because the order of differentiation is very important. So this partial derivative is obtained by differentiating this z partially with respect to y first, that is this y, then x, and then this y. Therefore it is dou y, dou x, dou y. But this is obtained partially by differentiating this z with respect to x first, then y, and then again y. Therefore you get dou cube z by dou x dou y square. So if you want, you can keep on calculating the higher order derivatives, and if you want to know how many will be the next fourth order higher partial derivatives, there are going to be 2 raised to 4. So that is equal to actually 16. So if you look at this chart, it is easier to remember it this way instead of remembering it as a theory. So use this chart, rewind this video, pause in between, just have a look at all these partial derivatives, try to understand, and if you have query, please ask me in the class. Thank you. Thanks a lot for listening. Yeah, and one more thing. The next video is about solving of the example. So I'm going to take one simple example and I'm going to illustrate how do we solve partial derivative examples. Thank you.